It's so satisfying every time.
It's fun. I like that. I was watching the video again a little more closely, and I saw today. Welcome, everybody. First of all, I'm Clever Like, joined by my buddy Gatlin Shadow, our creative director. How's it going, Gatlin?
I'm doing very well. How about yourself, my friend?
Yep, I'm awesome. Pretty excited about this. This is number 3 of our 5 hour of code projects that we created for Unreal Engine so that you could learn robotics inside of the actual physics-based environment of Unreal. Meanwhile, because, we like to sneak into vegetables, so meanwhile, you're learning robotics and having fun, but you're also learning how to use the Unreal Engine, which is going to be a gateway to many careers in your future. That could be really fun and rewarding if you like working in those kind of creative spaces. It's innovating many, many industries, and you pick up those skills along the way. Makes it easy for you to find the path that is most interesting for you. So that's really cool. So today we are on third lesson, which is line following, which we also called a delivery robot. So you think of now we have all these cool things, this cool city. You should show Robotown again. Yeah, look at that. Robotown. So you see, you have this playground. It's kind of like those toys you see advertised, where they have the set all made for you. So you have something like this where you can start putting a lot of your creations to work. And these are a lot of examples of them already working. But today, last time what we did was we built a sumo bot. So we added a sensor because it needed to see the line and then turn around and stay in the circle. So the goal was keep the robot in the circle, and then you have to eventually build a good enough robot to force a different robot out of the circle. So that's where the competition gets really interesting and creative. And now today, we are taking basically the same setup. So, but instead of seeing the line and then just doing some sort of turnaround and then going back to driving again, what we're going to do is in real time, we're going to be driving straight using the line as our guide, using a single sensor. So you think about how would this one eye that can only see light or dark follow a line, and you'll see how that works and how that gets implemented and how it's your next step along the process. So without further ado, Gatlin, are you ready to show us how it's done?
Oh, am I ever?
You are always.
One of the things that I definitely want to preface is that, what you see on screen is Unreal 4. If you're using Unreal 5, this totally works in there too. There's one little tweak that you'll have to worry about. There is a link down in the description on getting started with this, and it has said little tweak that you need to do inside of it. So I'm not going to cover it here because I'm in Unreal 4. I'm not in 5, so I can't show you how to do the tweak. It's kind of a thing. Yeah, so essentially, when you start this, if you haven't already started in Robotown, really what we want to do is make sure down here in the content browser, just search for this Unreal Learning Kit robots. I'm going to zoom in on this one, right? So the Unreal Learning Kit robots right there. And then inside of here, if we scroll down a little bit, there's a maps folder. And inside of there, we're going to be in L3. So this is lesson 3. So this is where you want to be for this specific video. Inside of here, go ahead and open this up. I'm going to zoom out though. If I open up this one, you will see that we have 2 of these maps inside here. So we're going to be in this first one. So this 3-1. So I'll just double click on that. And inside of here, we're going to have something kind of similar to what you just saw in Robotown, but all I have is just one single line. And what we're going to do is we're going to make this robot actually follow this line till it meets this little gate up here, right, this little bad boy. And then once it gets inside of there, we're going to get a little surprise. So surprise, surprise. We'll have to wait and see what that actually is. And essentially, really all we're doing is just making a line following. That's all we're doing inside of this one. And it's actually pretty simple. We're going to kind of cover some of the stuff that we talked about in the previous video. So don't worry about that. If you didn't catch it, we're going to go ahead and kind of get you up and running. And I'm also going to show you a kind of way to get up and running even faster if you need to. So to get up and running faster, let's talk about that first. You can actually grab your robot from the previous one and bring it in here. If you want to start from scratch, you can do that too. If you do bring in your other robot, just delete this one out of here. And when you drag your robot in, you may get a little message that says, hey, by the way, you're putting this outside the bounds of the level. Just say, okay, you're fine. That's good to go. I'm going to completely and start from scratch. And the reason that I want to do that is just in case you haven't seen those other videos, you'll be up and running and good to go. So no worries there. Where can you find all this stuff? It's all down in the description, but you can also find it on this Let's Train Virtual Robots. And if you come down here, to lesson 3, the self-driving car. I'm actually going to be working inside of this student guide right here. Right. So that's the one we're going to work inside of. And it looks very much like this. It's just basically a PDF. And at the very top, you should see this one. So yay, we're in lesson 3, like so.
It's so pretty.
Yay, pretty shot. This one's my favorite. That's my author. I like that one. Well, the Batmobile one's kind of fun too. So just saying, it was a good time. Inside of here, something I want to point out before you even get even further. If you scroll all the way to the bottom and then go up just a little bit. So on page 35, you will find this right here. So this observation log, this is going to be really helpful for you, especially teachers. If you're watching this, print a couple of these suckers out or put them on a whiteboard or project them on a whiteboard. So you're not using up paper, whatever it is that you need to do. And the students can actually write down their observations. The observation log looks like this. So we have one for lesson 1, even though it says activity 1, activity 2, and then activity 3. And you'll see that we have a spot here. You can record the threshold, how fast the motors are actually going, right? So moving toward the line, moving away from the line, and then a spot for your actual information that you need to write inside of here. Students, y'all can make one of these on your own. Other teachers, you can make one of these on your own, but we want to make sure that we have all this stuff for you. So just in case you don't have the resources, you'll be ready to go. And the links for this are also down in the description. So you'll just have a shot for it. No worries there. I'm going to go ahead and close this one down, and I'm going to move up to the top of this. And from here, what we're going to do is basically just kind of follow this step by step. Of course, I will be dropping in little tidbits that aren't actually mentioned inside of this, because there's some really cool little things you can do just to kind of like speed yourself up and make your life a whole lot easier. So essentially what we're going to do is let's kind of talk about the actual sensors, because if you haven't watched the previous video, I want to talk about that. And what you see here, this right here, is the actual sensor, and it has a distance from the ground, right? So that's what this little guy is talking about right here. And at a certain point, if it's too far away, it's not going to register anymore. And if it's too close, it's going to be too close, right? We designed these in a way so that they'll mimic what goes on in the real world. If there's too much light, then it's not going to work real well. If there's not enough light, it's not going to work. It's like there's this Goldilocks section kind of like right in the middle. So we have to kind of worry about that. So make sure that it's at a nice height away from it, right? So let's kind of talk about the environment that we're going to be working inside of here too. So the robot's going to be placed on the ground where it's going to be facing the line that it must actually travel. The line has got to be kind of smooth. So if you're making your own, because you can actually use all the tools that we have inside of this kit to make your own, if the curve is too sharp, you're going to run into issues, or it's just going to come off that, and then you're just going to have all the issues, right? So it's just not going to work. And the driving surface should be flat. You can, of course, undulate it if you need to, but it's going to work better if it's not kind of up and down and all over the place. Okay, so we're limiting some factors that are going on in there. Your robot must be able to drive by itself. You can't get in there and move it, right? Like that's not allowed. We're not in the real world. There is a way to do that, but I'm not going to show you that, right? The robot will start driving immediately as soon as we hit the play button. That's going to be awesome. If it strays away from the line, make sure that you just stop the simulation and then just fiddle with the code and then go back and fiddle with it a little bit more, right? What it needs to do is see, quote unquote, see that black line underneath it and with the white border. Okay, so it's going to be looking at that black line and the white border that's on either side of it. What it's going to do is it's going to drive away when it sees the black line, and then it's going to turn toward it when it gets far enough away from it and it can't see that black line anymore. So essentially what it's doing is it's kind of like wiggle along. If you're watching the beginning of the video, you saw the robots kind of wiggle, right? So this is kind of the setup for what we need to understand before we jump into it. So now let's actually jump into this. So I'm going to take this, move it over here on the side.
The cool thing about this, like, is how it's like you complicate it in your mind. Like, it needs to follow the line, and so you're thinking like it needs to see the line, and it needs to follow it and step on it and keep on track of it and not lose balance and all these other things. So like whatever your mind thinks of like how you would follow the line translates to the robot to 2 simple steps. If I see the line, turn away from it. If I don't see the line, turn towards it. And that's it. That's the solution. It's as simple as that. So, and then we put that into code, and we use a special type of turn that we've learned that keeps us moving forward while we're doing those 2 things. And that's it. So problem solving in games and technology and things like that sometimes takes complex thought process and turns it into simple actions.
Yeah, absolutely. Keep it as it's the KISS rule, right?
Yeah.
Keep it like super simple. Don't get crazy with it. Don't over-engineer it. I'm horrible at that.
Oh yeah, that's. I mean,
I'm so bad. I'm like,
I call that brainstorming when I over-engineered something. I'm
is
like,
that what it
that's
is?
just
Okay.
brainstorming. Yeah.
I appreciate that. That's nice. Okay. So if you are having a hard time kind of navigating inside of the world or actually placing things inside of the world, we have a robot kind of already set up for you. Over here inside of the Learning Kit robots, inside of Blueprints, inside of robots, inside of L3, there is one in here that actually already has the sensor on it. It's the third one over. It says BPC robot follow line underscore sensor because it has a sensor on it. If I drag this in and let go, here's that little thing I was telling you about. Say it's placed outside of the bounds. Just that's fine. Just hit OK. This one already has the sensor on it, right? So you can see that orb right there. So you can use this one, kind of get yourself kind of a head start. There's no code in it. It just has that extra piece. I'm going to start from scratch. So I'm going to there, get rid of it. Okay, I'm going to select my robot. I'm just going to press the 2 key on the keyboard. You can see it's kind of lined up and ready to go. But at the 3 key, I can see it from the side. So perfect. This works really well. With this robot selected, there's a couple ways to get into the blueprints. My personal favorite is just to hit Control E as an echo, and that will just open up the blueprint. This will allow me to kind of just start working on it. You may get a floating window that just kind of hangs out somewhere here. That's fine. Grab this part of your tab and just drag it up here, and you can dock it up with the other ones. This is really nice if you've just got a single screen. So I'm just going to grab that and drag it up there. If I click on the viewport and zoom out a little bit, you can say, hey, here is my actual robot. So that's the same one. And this little icon right here is going to be your clue for where we can actually put that sensor. So let's add the sensor, right? So to add the sensor, we're going to come up here to the components. Now I did this in the previous video, so I'm going to go a little bit faster this time around. So add components, and I'm going to type in light. What I'm looking for is this BP light sensor right there. I'm just going to hit enter since it's highlighted. You'll see it's dropped down here in the bottom, and it's right in the middle of my object here. So I want to grab one of the little arrows on here. So I'm just grab this and click and drag it, move it forward, and you'll see that it's facing this direction, which I don't want. So we're going to go ahead and rotate this 90 degrees, and I'm going to use my snaps up here in the top right. So I can turn on my snaps up here. So I'll click that on if it's not already on. And then change over to my rotation tool. So I'm just press E on the keyboard as an echo, grab this part of the gizmo, and just rotate it down. Boom. And now it's facing straight down. I'm also going to press W so I can use the move tool and just push this up just a little bit because I like it right about here. This isn't really going to affect it whether or not it's higher or lower too much, but we definitely don't want it to be like halfway inside of the robot. That would be a bad thing. Bad things will happen. Actually, nothing will happen.
And that's a bad thing.
That's a bad thing, right?
For most moving people, nothing is bad.
Right. So if you're interested in like where exactly this thing needs to be, if you're really, really curious, if you go to page 11, you can actually see exactly where this thing is located at. If you're like really, really want to be like perfectly perfect, right? And this is like, you know, it's a little subjective in my mind. I'm an artist more than anything else. So I'm like, it's close enough. And Clever's like, no, it's not. It's not going to work. Like,
no, it must be absolutely what I say or else.
It's going to be that thing, right?
So just to can make the connection, like if you've worked, I did a lot of work with Lego Mindstorms, and the trick we would use with the light sensor was we would use one of the beams. So that was the test. So your sensor should be one beam above the ground to get kind of the best. There was enough room for the light to reflect back to the receiving sensor, and it was close enough so that it got a good amount of light, so that the readings were pretty strong. The further it was away, the more unreliable it was. And then if the robot got bumped and the sensor got bumped up a little bit, it got even further away, and the values got worse. And so that's why, like when you have it close, if it bumps and moves, if it ends up moving away, it's still within range. But yeah, if it gets, if it kind of suffocates the light by touching the ground, then nothing happens, and that's bad. So
yeah, that would not be good.
Yeah.
So, and we can kind of see how far away it's going to be from the ground too. So if we actually look inside of here in the actual level, so in the level here, I can actually manipulate what's going on from inside the blueprint. So if I grab that, I can move it and you can see where that's going to be located at. So obviously I don't want it down here. That would be a bad idea. So I can just set it about there-ish. And I'm moving it here, but I'm watching what's going on over here. Right? That whole hand-eye coordination thing, something about video games being good for you. I don't know. Tell your parents. Now, the other thing I don't want to do is I don't want to set this way out here either. That would be bad. Like we want it to be here-ish. Otherwise, because what's happening, and I'll just kind of move, let's hit 2 on the keyboard because it's going to work a little bit better. Our center pivot is kind of like right here. It's actually this in blue is right here. So the robot's going to kind of rotate around that where the wheels are, right? And if this sensor is like way over here, we're going to have problems. Like we have to kind of set this up in a way that we're going to have the most success. So that's how to add it and where to add it, which is good.
Could be fun for you to experiment if you're curious how that would work and be like, like failure is a great informer when it comes to robots, and it's almost guaranteed. And you'll be like, ooh, did not see that one coming. That's pretty good. That was funny. Okay. Well, thank you. Duly noted. So you keep track of all those things. So lots of failure and accidents are good information.
Yeah. And a good scientist will always go through and like document their stuff. So if you don't have a screen capture, buy some really expensive phone and use that to capture what's going on, right? Like there's always some way to like kind of see what's going on. But let's go ahead and start to build in the code. So I'm going to move over to the event graph. And that event graph you can find up here at the very top inside of my blueprint. I'm just going to go ahead and just click on that. So we have our events over here on the left, and we have our run motor stuff all over here. And this is mostly where we're going to be running the code. So if you are following along in the video, or sorry, in the document, I'm basically on page, let's see, it was basically 14 is really where I'm at. What I want to do, so to navigate real quick before I go anywhere, to navigate inside the graph, right mouse click and drag, and you can kind of pan, and then you can use your scroll wheel to zoom in and out. And then your left mouse will allow you to select things, and then you can click and drag and move them around too. Control Z is a fantastic thing. It's undo. It's awesome, right? So what I'm going to do is I want to, as soon as the game begins to play, I want to go ahead and run this robot event. So to make that happen, I'm going to click on this white little home plate pin. I'm going to click and drag and create a wire. Now, when I let go of my mouse, it's going to ask me for some kind of thing. What do I want to put in here, right? Well, I want to run that run robots one. So if I type in run robot, we'll see this call function, run robot. So boom, there we go. So now, as soon as the game plays, we can actually run the robot. Now we could have just connected, all the code to this, but we're going to create a loop, and having this specific node is what's going to help us create that loop. So if you're like, this seems redundant, it won't be in a minute. So there's that. All right, so moving on. If we go down to page 15, what we need to do now is we actually need to get that sensor. So this sensor right here, right? So if we select it here, we can also select it up here, right? And go into the event graph, and now I can click and drag that one because I know which one it is, and I'm going to drag it down here into the run motors area. So this is my light sensor, and we want to make this sensor run. To do that, I'll zoom in on a little bit. I'm going to click and drag on that blue pin. I get a blue wire, and when I let go, I'm going to type in run sensor. Oops, actually, let's do run light sensor with threshold. So we were using, if you'd seen the previous video, we were using just a run sensor. We're going to use with threshold. We've actually built in the Boolean, the yes, no, the branch is what it is inside of Unreal, actually inside of this. So we're going to save you a step. We're talking efficiency here, people, efficiency. Nice. And you'll notice that this sensor is now connected to the sensor input on this one. So you're like, sweet, that works awesome. Now let's take our run robot from over here on the left and connect it to our in on our macro. So this is a macro node. You can tell by that because of the little icon that's right there that looks like a gear. So let's talk about some of the things that we have on here. So our first little knob that comes in here, little pin, is our sensor. So this is the sensor that we're using. So if you have multiple sensors over here, this one is this one. So we know that that's the one that's actually going to be run. So you could add multiple sensors. Spoiler alert, right? So our max range, how far away are we actually going to be looking from the sensor to where it's going to stop looking anymore? And this is why we were talking about this earlier. Let's go ahead and zoom in on this if I can get it to do the thing here. So this distance from the bottom of the sensor to the floor, what is that distance, right? If it's less than 200, then perfect. So if it's less than 200, it's centimeters, then we're good to go, right? So that's 2 meters. It's going to look about 2 meters away. Now we have our threshold because we have it built in here too. So we're going to leave it at 60 just because that's going to work really well. And what that means is while we're looking at our, let me get a decent shot of this, a little feedback up here. So we have a white side over here. So this is above 50, right? So it's looking at the white area, right? And we have a below 50 right here. And this is looking, how much of the dark am I actually seeing, right? And that sensor is going to be doing sorry, I'm going to do this in red, but it's going to work. It's going to basically be looking at this area, right? So if it's right on the middle of it, we're going to get like 50%. So if it's less than that, less than 60, it's going to be like, oh, I need to do something. And that is what this little thing is doing. So as soon as it hits lower than that number, this 100 right here, as soon as that reads lower than 60, it's going to do something. So I'm like, cool. So we'll leave that at 60. Hopefully that makes sense. It'll make more when you kind of work with it. If the draw sensor isn't toggled on already, go ahead and turn that on so we can see that sensor as it works. Okay, so that's what this node is going to do. It's going to give us feedback from our sensor and make our robot do a thing. Now, to get this, remember that loop I was talking about? We need to take this run robots and we need to add it over here to the side, right? So this is on page 18. So I can select this, right? And I can Control C copy, Control V to paste it wherever my cursor happens to be. And now it's connected. Now, to make sure that this is going to work, just to make sure that the sensor is going to work, we're not going to make the robot move just yet. We just want to make sure that it's going to work. Take your threshold less than and equal to and your greater than, and plug them both into your run robots, right? So it's going to look like this. It's all plugged in. And now, because we've changed a lot of the code, we're going to go ahead and compile and save. Now I'm going to just move this off to the side here because I want to be able to see the code firing down here in the bottom right while my robot is actually running. So at this point, our robot's sensor should work. So to test that, we can just hit the play button up here. So I'm going to just click that. And now we get these little lines that are actually popping out down here. So this is cool. I'm going to go ahead and eject real quick because I want to show you something. So I'm going to eject myself. And now I can actually select my robot and move it around. And you'll notice if I go up far enough, you see that it stops sensing. That's that 200 limit. Like it's not doing anything, right? And as I push it down, watch that sensor feedback. So you can see this value right here. It's going to change depending on how much, because it's looking at about this much area, right? You can see that it changes. So as I move further and further away, it's like, oh, I see nothing but light. Whoops, if I get high enough. So it's seeing nothing but light. So it's 100%, it's white, right? And now I'm starting to see a little bit more and more of that black, more and more and more and more and more and more. Cool, so there it is. So that's how that's actually working.
It'll get more reliable the closer it gets to the surface. So that's kind of mimicking how the real sensor would work. And then you could see basically you get a more narrow focus. So you could also get more reliability on detecting edges and things like that. So yeah. And I feel so bad about what we've done here. I feel so guilty because yesterday we taught them like the hard way to do it with the sequence node and stuff like that, which is really useful and valuable. But then we packed all of that complexity into this little macro. So this run light sensor with threshold kind of takes care of a lot of the dirty work we did yesterday. So sorry about making you do that yesterday, but this is the shortcut. Now you understand at least what we're doing behind the scenes.
Something about a teaching experience. Something.
Yeah, we did it.
It's a thing.
Yeah.
Okay, so we know our sensor works. Awesome. At least for me, it's working. If it's not working, drop something in the comments. Let me know what's going on in there. From here, what I'm going to do is I'm going to scroll down on my sheet over here, and I'm going to go to page 21. And on page 21, it talks about using the threshold calculator. Now, there is a threshold calculator worksheet in the description down below, so you can grab that too. So you can actually go and say, well, how much of the white am I seeing? How much of the black am I seeing? What value am I actually getting back inside of this threshold? Like how is that being calculated? That worksheet will do that for you. If you don't have access to paper and pen, that's fine. You don't necessarily need it. What you can do is if you go into the blueprints and then to robots, move this out of the way, you will find a threshold calculator. So if I right click on this and at the very top, it says run editor utility widget. Ta-da! And then you get this. So you can put in your white value, right? So this is your white value. How much of the white am I seeing? And then this one is how much of that black am I actually seeing? Okay. And then it'll actually give you your threshold over here. So let's say, and you can type in here. So let's say I'm seeing like 20 on the white and I'm seeing like, 45. And I say calculate. Well, I'm like, cool, I'm going to get a threshold of 32. And that's how it's actually figuring that out, right? And you can use these as little sliders too, and then just hit run calculate and it'll actually recalculate.
Can you, right where you're at this, so again, kind of making a connection to Lego Mindstorm. The cool thing about the Lego Mindstorm, and that's the context that I have, your robot system may have something similar, but what it has is kind of like the ability to kind of like live read the value of your sensor, and then you could take your robot in your hand and you could say, what is the value when I put it here, like on the floor? What is the value when it sees the line perfectly, like the solid line? And you get those two. Those are kind of like your two things, is like my empty floor, my free driving area, and then like my line, and the most solid center position of the line. Those are your differences that you need to detect. Like, am I driving freely, or am I avoiding, or responding to the line? Those are the two states you need to detect. The threshold is the line at which the value becomes either seeing the line or not seeing the line. And so that's the purpose of the threshold. So Gatlin, can you kind of take us back to the, can you like stop this, press play and eject, and show us how we could basically grab this robot in our hand and move it around to get those values?
Yeah, absolutely. So with everything as is, I'm just going to come up here and hit the play button. And then immediately, before I even click anywhere inside of here, I'm going to hit this eject button right next to it. Now I can actually come over here and actually grab this, and I can lift it straight up.
So 36 is your,
lowest.
Yeah, go ahead.
Yeah. So 36 is the lowest I can get right now from where my sensor is located above the ground. If I go too far up, like you can see, I can push it way up here. So your threshold value, it's over here, right?
So black would be 36 on, go to your calculator and put 36 as black. That's what you would do, because we look dead center on the line. Now scooch it off the line, make sure the wheels are like, on the floor, and scooch it over so that none of the sensors hit the black line. And so we're seeing 100% on the light feedback in this scenario. So now we have like the darkest that we can detect the line is 36, and the whitest is 100, which is the maximum value that the sensor would read in this case. So you see the threshold is 68 in this case. So when the sensor, as you move your sensor across the line slowly, see how the sensor goes 49. What is the increment here? It goes 87. Up to 87. So when it goes from 40 that 49 to 87, it looks like there's even like a 69 increment or something like that in there as well. Depending on which way it's facing, it's going to change. But there's a point when, as it starts to cross the line, it's going to trigger, I see the line, and as it goes away, I don't see the line. That's the purpose of the threshold. There's other important aspects to it, like if there was dust on the floor wouldn't consistently see the same number. These numbers are constantly changing. So as they're fluctuating, you don't want your robot to get confused. So you take like a whole range of numbers and say, do the same thing based on this whole range of numbers. This way it accommodates for all those various inconsistencies. But when you're like, once you've crossed this threshold, you definitely are seeing the line, and now you need to do something different. So that's the purpose of the threshold, and that's kind of like why we're giving you this calculator to pick like the middle point of the sensor's best value for both of those conditions. Hopefully that helps understand how that works and why we're doing that.
Yep. And one last little thing that I'll mention on this too. So if I were to come in here and actually move this sensor down, and now I hit play, like you can see my threshold has changed. Like that black line is 15 now, whereas over here, then it's at 100. So the height on that is why we have this calculator. So now if I were to say, like, oh, this is 15 and calculate that. So I'm like, 57. So it has to be, that threshold should probably be lower than, 57 as it were.
Yep.
So that's where that's coming from. So let's actually move that. I'm going to undo and bring that back up. Cool. So that's where that works pretty well. Yeah, there's that. Once you've actually activated this thing by coming down here, right clicking on it and saying run utility widget, you will always be able to find it underneath window under your editor utility widgets. You can find it here too. So a couple of places you can get at it. Yay, thresholds. It's a really cool, like this is something I learned like hardcore. I was like, what do you mean, Brian? This is really weird. And then he had to go through and explain it. And then we started to build it. And I was like, oh, that's fun to play with. So from a game design standpoint, you can do some really cool things with this. I could go off on a tangent, but I'm going to stop. I'm just going to say there's some really fun things. Like, oh, wait a minute. Then I can do this and I can find these things. I was like, this is cool, right? So yeah, it's a lot of fun to play with. Okay, so now what we're going to go ahead and do is we're going to go ahead and run the motors. So if the motors are actually seeing the white line, it's going to do, point toward the black line. So it's going to go toward it. And if it sees so much of that black line, it's going to turn away from it. So we're just going to wiggle our way across it. So to make that happen, let's go ahead and just move this up here. And I need a little bit more space between my light sensor here with threshold. And I'm just going to drag this underneath and my actual run robot. And in this space in between, what I'm going to do is actually run in the code for the actual motors. It's going to be very similar to what we had done in the previous video, so not a big deal. To disconnect this wire, I'm going to hold down the Alt key on the keyboard, and I'm just left mouse click on it, and just boop, and then it just disconnects both of those. So I need a reference to my motors. My motors live up here. So we've got motor B and we've got motor A. So I can select both of these. Now to select both of them, what I'm doing is I'm just holding down the control key and I can click on them. It's like a toggle whether I'm selecting them, not the wheel. I want the motors. Yeah, make sure you get the motors, by the way. Look over here, get the motors, don't get the wheels. Right, so I can click and drag those in, and I'll get motor A and motor B. So there's those. So let's put these down here below. So if our threshold, right, so if this value on that little sensor is greater than 60, what we want to do is we want to go ahead and turn that thing, turn the motors so that we go toward the black line, right? So if it's greater than 60, we want to go toward the black line. So from here, I'm just going to pull a pin off of there, and we're going to type in run motor. And I'm just going to use the run motor, not the run motor over time. So use the run motor. And which motor do I want to be running? I want to run motor A. So there's the first one. Now, motor B, to make it turn, I'm going to have that second motor stop. And that second motor, and show you where these are at. Actually, if I hit 2, this works a lot better. So this is motor A on this side, and this motor B on that side. So I want this one to roll so it turns toward by having this one not moving at all. This is exactly what we're doing here in the code. So I want to stop the motor. So I can pull off of this wire and type in stop motor. And I will connect this one to here. I am not going to have it coast. I'm going to leave this off. I don't want that to coast, right? And then I'm going to go ahead and tell it, hey, continue to run the robot. So like, cool. So this works. So what this should do is this should turn my robot toward that line. But before you go anywhere, we need to give it an actual speed. How fast do we want this motor to actually run? This is up to you. And there's a lot of values in here that'll work really well. And then there's actually quite a few that don't work well at all. If we use a positive value with motor A, we're going to get this motor to actually turn the robot this direction, right? Is what it's going to do. When I look at this from the side, a positive value is going to turn this motor this direction, right? So the ground is going to go that way behind it. So let's type in, I don't know, let's do something like 10. We'll keep it nice and slow for the moment, right? So that should work well enough.
I like how the ground is going to move. It's like such a video game concept. You got your player in the center of the screen, actually not move, not moving.
Not actually, yeah.
The ground is going that way, everybody.
It's going to be a thing.
I could just hear everyone's. It was deafening to me when you said we could put a number for the speed. I heard 1 million billion. Everybody was thinking what number they're going to put in the speed.
So
Stop!
much.
Don't do it.
And before we do this, I want to be able to see this code fire down here. If you're using your own robot, make sure that you change your debug filter up here at the top-ish up here. So this little drop down, I'm going to make sure that I've only got one robot in here, so it's the one that's selected, which is nice. But if you've got multiple, you can choose which one it is. Otherwise, you may not actually see the code fire down here. And you'll be like, why? And then you're like, oh, checkbox. Okay, cool. So let's go ahead and just play this. But and it stopped immediately. All right, so what that means is that my robot needs to be moved so that it is, actually hit the 2 key on the keyboard so I can see this, that little sensor. So what I'm doing is I'm looking at this sensor in relation to this black line that's right here. Boy, hopefully you guys can see that. That's like really dark. I want to make sure that that sensor is to the left of it to start with, right? So now if I hit play, it'll start to roll, and then it just kind of stops. But the motor is still going, right? So it's still turning. So it was definitely turning, it's definitely turning toward that dark line. But as soon as that threshold got lower than 60 at 49, it just stopped. Like the sensor's not running anymore. But the wheel's still running because we told the wheel to run. So that's the thing, right? We never told it to stop. So we want to use kind of what we've got here and actually get the other wheel to start going if it goes below that value. right? So we've already kind of got the code built here, so we can just kind of copy this. But before we do, we should probably comment this so that we know exactly what it is that this is doing. So what I'm going to do is select all of these like I have here, right? And I'm going to press the C key as in Charlie, and I'm going to say turn toward line. TWORD line. There's an A in there, isn't there?
TOWARD.
ARD. Yeah, there we go.
TOW.
OW. Yeah. As I say, not as I W. As I W.
Big.
As I W. Good Lord. It's been a day. It's been a good day. All right.
I just put 2 line. There you
Two
go.
line.
2 line.
But there's only one. There's only one. All right. So this whole set of code we can basically reuse, right? So I'm going to select all of it, and then I'm going to move my cursor up here. And this time I'm going to hit Control W, and Unreal 4 to duplicate is Control W, and Unreal 5 is actually Control D. So if you're using 5, there's a thing. Boom. So there's that. But in this case, I don't want to run motor A. I want to run motor B. And I don't want to stop motor B. I want to stop A. So I just need to transpose these two. So these two need to switch spots. So I'm going to disconnect them. I'm going to hold down the Alt key on the keyboard and click on the pins. It's going to disconnect the blue. All right. Then I can take B and I'm going to set it over here. Take A, move it over there. Right. And then just connect these up like so. And then I need to make sure that this threshold is actually connected to my motor. So right here. And then I'm going to take the out and I'm going to have it run the motor. So now we have a loop that'll continuously run over and over and over. Now, what's the other thing I need to do here because I've changed the motors?
Mm-hmm. Mm-hmm. Ooh.
Mm-hmm.
I'm paying attention. I know how this works.
Yep. So first I'm going to change the comment. Well, I'll let you guys figure out what it is. Right. So this is going to be away from the line.
Mm-hmm.
Like you got your hand up. What do I got to do?
Okay, so remember this motor is 180 degrees different. So in order for the ground to move the same direction, the motor needs to be in a minus rotation because that will put it in sync with the forward movement.
Right. So we need to make sure that motor B is a negative. Same value. I'm going to leave the same value. So 10. We're going to leave that as the same. So I'll go ahead and compile and save that. I'm going to move this down here. And now what we should see, I really like this because this is like, I apologize for those that are light sensitive because we're going to get a little bit of flashing. It's going to be going on down here. It's not bad, but it's definitely a thing, right? So what should happen, right? So our theory is when we don't see the line, this is going to turn toward that black line. When we see so much of that line, it's then going to turn away from that line, right? That's what it should do. And it's basically just going to wiggle its way across it. So let's go ahead and hit play.
Jiggity, 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 jig, 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 ding, ding, ding. Look at that. Yeah, you got the disco strobe lights going.
Right, so we can see that sensor feedback as it's jumping back and forth. And you can see down below the code is oscillating. So now this thing is slowly going to make its way all the way to the end. Now, this is why I'm saying if you've got a curve when you go to make one of your own, if you've got a curve that's really tight, depending on how fast your robot's going, you're going to have some serious issues. So be aware of that. Right?
Turning radius and speed is a thing, and that's another thing that will annoy you. It is a seed of frustration that has been planted in your garden of learning.
So we're going to get all the way to our little parking spot here. Now, something's going to happen. I'll just let it run because I think it's kind of fun, right? And when this happens, you can customize this, by the way, about what's about to happen. I'll wait for it. Yay, we get some particles and we get a little present that pops out, right? You can go through and change those particles. You can change that present. You can you can add sounds. There's some sounds that actually, I don't know if y'all could hear that, right? But as soon as it gets to that point, it's actually causing some code to fire. So real quick, we're going to take a quick tangent because I want to show you where this exists because I want you to like do this, right? Maybe you want to spawn like all kinds of, I don't know, whatever it is, something that you made inside of ZBrush, just saying, right? So that code actually is not in the robot. It's actually inside the level. And this little block right here, and I can't select it because I've got the level locked, but as soon as this is actually touched by the robot, something happens. And that something is this event. So if we come all the way up here into our blueprints up here at the very top, and I click on the little drop down, actually I think I have to, yeah. So I just click on that. You will find a spot here that says open level blueprints. This is the blueprint for this entire level. So I'll open this up. And oh, I'm doing it wrong. Sorry. This level doesn't have anything in it. That's why it's all locked up. So I lied to you. I'm a jerk. We actually need to open up the level that some of this other stuff is inside of. So quick detour. Sorry. We're going to need a window, go into levels. And instead of here, we've got one for the environment. This environment, if we come follow this all the way over to the right, you find this little controller. It's in this one. So I'm going to click on this one. There we go. That's the code I'm looking for. So this environment, when this block gets hit, that's that little end goal. That's this little block right here, right? It's going to make sure that the robot is actually hitting it. And then it's going to say, do this one little thing once, right? It's going to play a sound. It's going to set the visibility on present. There's a present that's hidden in here. You can't actually see it. It's there. We just have the visibility turned off, right? And where that present is, we're going to go ahead and spawn some particle systems. So this little drop down will allow you to change whatever particles you want to actually change this to. I suggest not using the sky clouds. Just, I mean, you can, but it's really not going to be much. You can't see much, right? They're just background pieces, right? But the winning confetti is what it's actually working on, right? So this will allow you to go through and kind of play with some code that's buried. It's a little tricky trick that's buried deep inside of here. That's a lot of fun to play with. Record your own audio, sculpt your own models, make your own particles, and you can make it do kind of whatever you want, right?
We have some extension activities in here.
Yeah, it's a thing, right? Okay, so how much time we got? We got heck of time in here. Cool.
Heck of time.
So what I want to do here is we're going to take this to another level. And instead of, if we've got time, instead of actually putting 2 sensors on this, which we can totally do, and make it a lot more efficient, we can speed this up and slow this down. And I want to show you how to do that by using public variables, because public variables are great and they're fantastic for video games. It allows designers to like change something on the fly without having to go into this code that you see. This includes you in this case, right? So what I'm going to do is you notice that the speeds here, this one is a -10 and this one is a +10, right? Well, what we can do, let's go and do this toward the line first. I'm going to right click on this and you'll see there's a little option here that says promote to variable. So now I have a variable that I can change on the fly when I want to change the speed for this motor. And then you'll also notice as soon as you do that, you get this little variable down here in the bottom left-hand side that says speed. And just to the far end of it, there's this little icon. If I click it, it'll turn into an eyeball. What this does is it allows me as the designer, while I'm working inside the actual level, is to change this variable on the fly. Now, we need to do one thing before we're actually able to do that, and it's because I've added code, I have to compile. Okay, and you'll notice, please compile this blueprint, because this node doesn't know what it needs to do yet. So I'm going to go ahead and say compile, and you'll notice it dropped in that 10. I'll go ahead and zoom in on this. It dropped that 10 value in there automatically. So yay, we know that that's a 10. Now, let's back this out of here. What we will see, let's go ahead and move this off, is if this object is selected, I'll zoom in on it, right? If this object is selected in the details panel, I now have a little area that says default for 10. I hope you're all still with me. See where this is going, right? So if I change this, and I change this to something like 50, right? Now I hit play, right? Ooh, it's moving a little faster, right? Now this is only controlling that one wheel, right? So if I bring this over, whoops, come here. If I bring this over, it's only firing this bottom one faster at 50. It's not firing this top one yet at -50 because that's -10. But, already, are you ready for this? Here we're going to do. We can actually hook this one up here, but that's going to give us a +10, right? We don't want +10. We want -10. So this is where our math starts to come in. I'm going to give myself a little bit more space. Whoops, if I can get a hold of everything here. I don't want to move. All right, fight me, machine. There we go. So just so I can isolate this speed value. So our speed is 10 going into here, but I want to have a -10 coming through here. So I'm going to pull a wire off of my speed value, and I'm going to go ahead and type in asterisk or multiply, right? And then what I'm looking for is this float times a float, because this value is a float value. It's got a decimal point in it, right? So if I use that, now I can take my speed and I can multiply it by -1, ta-da, and this can be pumped into there. So now I'm going to compile and save that. So now what we have is this speed variable we can change while we're in game. Let's make sure we save that. We can change this while we're actually, sorry, not in game, in editor. We could change it in game too, but we're not getting into that today. We can change this in the editor. And now if I type in 50, we're going to get positive 50 for wheel A and negative 50 for wheel B. So now let's hit play and see what happens.
Oh boy.
Oh, it made the corner.
Nice. Woo, that's fast.
Right? So you can see, you could actually get this going really quickly.
Yeah, nice, dude. Good work.
And depending on where you start your robot too, I'm going to look at it from above. What happens if I start it actually on the line?
There goes my warning about speed.
Right? That's
You
actually hit
nailed
3.
it.
I want to be over here on the side. This works a little bit better. I'm going to hit play. Right? It starts to wiggle. Oh, goodness.
Whoa!
Oh, I made it.
Wow. How?
All right, let's just try 60 because we can, right?
Yeah. Let's see this first corner here.
Oh,
yeah,
it's not gonna
buddy.
make it. So 50's fast, 60's too fast. What if we did something like 55? Right. So this is when you're writing stuff down in your observation log. This is something that you want to actually write inside of there. 50 was okay, 60 was too fast. What happens if I do 55? Ooh, it still made it. Like, that's pretty good. All right, so let's try 50, 58.
And remember the Dead Reckoning demo where it didn't behave the same way twice. Like in between sensor views, it could do its own thing each time. A little bit of variation could happen. Woo, nice turn.
57. Let's give it another shot. That was really close. That's a 57. 58's too much. 57's, so we'll do 57.5. You could push this down to like, tenths of a decimal, thousands of a decimal if you wanted to. Oh, look at that. So cool. So we know that we can probably, I wouldn't push it any farther. So 57 is kind of our max, at least with this setup for what we've actually got going on in here, right? So what we're able to do, so real quick recap, we can set our speed, individually in each one of these motors from motor right. Oh, AWAY, good Lord. Oh, whatever. So you can set them individually in each one of these. You can create a variable that actually you can change it. If you promote the variable, right, to make it public, you can actually change it in in editor.
Mm-hmm.
And you can actually set up a little math. So you only have to change one of them. And so it's changing 2 of them in here, right? So that's really, really, really helpful to actually get this kind of stuff up and running to make your life a lot easier, especially when you're testing over and over and over. Nobody likes jumping back and forth between blueprints and stuff. Like, that's awful. Okay.
That's cool. So the thing that I liked about that is that it highlighted the fact that the robot doesn't know what side of the line it's on. So for instance, start your robot on the other side of the line and then press play. Like turn towards the line. Okay, it's going to turn towards the line. So go ahead and press play.
Oh, hold on. Let's move it forward because it's running into the save me cone.
And it just turns away from the line, right? Because it's designed to be on the left side of the line. And that's its assumption, is that I am on the left side of the line. I will turn towards the line to the right. I will turn away from the line to the left. And that means if it's going too fast and it gets to the other side of the line, it's going to see the floor. It's going to think, oh, I'm on the floor. I need to turn right towards the line. And that's when it goes and starts spinning around in circles and gets out of control. So that's where you start to think, man, that's dumb. Like, why don't we come up with 2 sensors so that the one could see it? And like, yeah, that's the idea. Like, so then you would put 2 sensors and that makes your code more complicated, makes your thought process more complicated. But that's a great extension activity for this, for this exercise, is like, how do I make it faster now by adding another sensor and get more reliability? You could even add 5 sensors if you wanted to and increase the speed. Like, how far can you go? How fast can you go? If you search line following robot videos and things like that, there are some videos of robots that have like a whole array of sensors on the line and they go lightning fast. Of course, they're designed very well with the way their wheels are making traction to the ground, the balancing, and all the other construction details. But the coding is also very sophisticated to kind of manipulate those motors in response to the surroundings as best as possible. So anyway, that's the great thing about this. It's a quick way to do it. It has shortcomings. Those shortcomings are the seeds of frustration that make you want to do more. And that's what we want to see you do, is like, how can I push this to be better?
Mm-hmm.
And you can do it.
And that's actually a really nice segue too, by the way. So this other map that I was just highlighting down here, if I open this one up, it's going to say, hey, do you want to save the things? Yeah, save your work. Don't forget to save your stuff, right? This other map, look how much more complicated this line is. And look, there's actually little obstacles.
Mm-hmm.
If your robot goes too far one direction, it'll bump into these and it's not going to go any farther, right? So you can create, if we go back into our robots, so L3, right? So we have our one that we created, right? There's the one that we created. We can take this one and we can basically set it up. So if I hit play, it'll probably follow it. Yeah, it's not doing too bad, right? That's not doing bad. Now it's only set at 10. So if we set it at what would we say it was, like 50 something? Let's actually set it at just 50, right? And we run this one, like cool, like this will work, but look how much it's like it's moving away from the line, and that corner, it's not going to make that corner. I'm gonna be surprised if it does.
Go.
Oh, it made it. Look at that. Okay.
Wow.
So that's actually pretty good.
That is
So
pretty good.
where this is actually set up and how it's set up is going to be really important as far as those sensors, like where it's set up, where they're at. But if you can set up a second one on there, you can make it go from one place to another and much faster, just like Clever Like was saying. And we highly suggest doing that. Now, you don't have to destroy this robot that you made. Okay. You can use this as a basis and hold on to it. If you select this down here, right, and just right click on it, you can actually duplicate it, right? And then give it a new name. So line, we'll call this one Shadow. With caps too. So now this is my new one. And if I open up this one, it has all the code from what I was doing previously, right? It is a different robot. You can see that the name is different here, right? So this is the one that's Shadow. This is my new one. And then you can kind of rearrange and play and work with all of this stuff because you've already got it. And it's not going to destroy the original one, the one that I've got on screen now, right? Not this one over here. Move that out of the way. Whoa, come on back now. Because you can see that it actually gives you the names up here, right? So there's that one and there's that one. So you can tell which one is which. Real quick and easy way to make that a thing.
So here's the thing that could point out to people. First of all, what do you notice about the motor selections that we chose, right? We chose what type of turn is that, where the one motor moves and the other motor stopped. Pause for reaction. Okay, I heard you. You good? You jumped in. That's great. It's a pivot turn, right? So the thing about the pivot turn is like you're not, one of the motors is not moving and not making any progress at all towards the destination, and so that's really like just wiggling, like hardcore wiggling back and forth. And so you might think, what is a way that I can make a little more progress here, not thrash around so much and be smoother? Now, there's two levels to consider. The first level would be to enable coasting so that the motor doesn't break. So it stops moving, but it will roll with the momentum of the robot. And so that way it's not thrashing around so much. So if you turn on coasting, go ahead and turn on coasting and then run it again, Gatlin, if you could, even on the difficult map that it managed to work.
3, that one. Save all the things. Okay.
So this one, we turn on coasting.
And make sure you've got the right one. Coasting is on. Coasting is on. Okay. I'm just hitting Control E to open up the editor, by the way, just so y'all know how I did that really quickly. Oh, yeah. That takes huge. Yeah. With coasting on, that's no bueno.
Yeah. So the coasting, if you were to time it, it moves faster. So increasing your motor speed while it's thrashing will make it turn faster, but reducing your speed and leaving your coasting on so that both motors are moving and making progress. There's some difference there, and that would be something for you to experiment and assess. You could also move both motors forward at different values. So coasting would be like letting it coast, versus like setting the speed of the other motor to something lower, so you do more of an arc turn. And so I encourage you to come up with your own solution on what is the best way to make this work, and then throw these different scenarios at it and see which one works best for you. So this is where a lot of the fun and frustration comes in, and you predict what it's going to do, and then it does what it's going to do. And maybe you were right, maybe you were informed.
Right. And just with one sensor, like that thing's hauling. That's pretty good.
Yeah.
Yay, we win.
Ooh, and you caught the present.
Yay. It just hangs out over there.
Yeah, he's like, no, let me at him.
Yeah, so we don't have code in here to like make it stop when it gets to the end. So you guys can figure out how to do that. That's another fun thing, right? Like this is, we've been working on this for, I don't know, a year and a half or something, kind of playing with it. And like all these tiny little things that you can take to extend this even farther. I'm like, okay, we can change the presents that are there. We can change the robots. We can change the coasting. We can change, we can get in here. Like you can make your own lines. Like you can create your own courses. Like the sumo battle is just the beginning of it, right? Maybe there's like certain areas with the sumo battle, you don't want things to, like there's little areas where other cameras are like people are hanging out in VR, just saying, right? So you don't want the robots to get close to them. So you draw a little line around them, maybe. Like there's crazy things that you can do inside of this. Just so much fun to play with.
Wait, Gatlin, you know what would be really cool? If you could tell like how close you were to something. And so once you got like close to something, then you could stop. That would be so cool.
Oh, so you mean like self-driving cars?
Yeah, like if a car, like, if you wanted to stop, like when something's in front of it, like if you had a sensor that could like see what's in front of it and then stop, that would be awesome. Like that'd be perfect. That'd be what we need.
Okay, but this sensor just sees light. It doesn't actually check. I mean, it kind of checks distance, but I think having just like a distance one by itself would be really handy.
That would be, that would be so useful because then you could have it like know that it's at the destination. You could have it like avoid things that are in its way. Like, that could be really cool. It's too bad we don't have that.
I think you're onto something there. I think you're onto something.
Stay tuned, folks, for the next exercise. Activity 4, we get to add a new sensor. A laser distance sensor, often referred to, or that you could find in something like a LiDAR sensor, which is a laser-based distance sensor. It's very accurate, has good range of distance, and is now like in your mobile phones. And a group of friends that we had a robotics club, and they built a self-driving full-size vehicle for a self-driving vehicle competition, but for hobby vehicles, they built a full-size self-driving vehicle, and their LiDAR the sensors that they used were thousands of dollars, and now these things are like in your phones and stuff like that. So these great technologies are pervasive; they're everywhere, and so you can, once you learn how to use these things, you can add new features, add new capabilities, come up with new creative ideas. And so on our next stream, we'll be talking about how to combine the intelligence, first of all, the feedback of a distance sensor, and then add that intelligence to inform the way your robot works, which is super fun.
Yep. Yeah, these things, like, oh my gosh. It's just so cool to kind of play with these because I keep saying this, and I'm going to keep saying it because I'm just so excited about it. I'm like, it's going to be amazing to watch what people actually create with these because
absolutely
all the pieces are just sitting there. Like, it's like, and that's one of the things that I very much appreciate about, all of this technology that's out there. Like, there's so much of it that's just like, here's the piece. And you're like, oh, cool. I can use a Raspberry Pi to do this thing. Or like, oh, maybe I want to go ahead and grab that thing off the internet and 3D print it and add it to the spring. And now I've got like this whole like automatic like setup thing, like it'll close the door. Like I'm like, what? Like this is insane. Like just amazing stuff that's out there. So, yes.
That's awesome. So that concludes our activity number 3. Thanks everybody for joining us. I hope you had a good time with that. There's lots of cool extension activities, that new map, and adding more sensors to your robot, starting to think like, how can I solve a new problem? So create a problem for yourself and then come up with a solution. So a lot of inventing is coming up with the problems and coming up with the solution, which is a lot of fun.
You make it sound like coming up with a problem with these things is going to be hard.
Yeah. Yeah. Keep a list, right?
Yeah.
You can pick your favorite problem to work on. Yeah. No, so it's super fun. Hope you guys enjoy it. Push yourself, enjoy it. And then we're going to be on the next stream here for anyone that's watching live. This is going to be, it's Friday today. On Monday, we're going to do activity 4.
Yeah. Be a thing.
Look forward to seeing everybody then. Gatlin, good job. Thanks a lot. That was a lot of fun.
Yep. I'll catch you all on the flip side.
All right. See you, everybody.